It was a time of unparalleled greatness. Dinosaurs ruled the Earth for over 160 million years, from the late Triassic period through to the end of the Cretaceous period. Their dominance over the planet was unquestioned, as massive herbivores roamed the land and terrifying predators stalked their prey. The Earth was theirs, a world where these mighty creatures had evolved into the rulers of the land, the skies, and the seas. Yet, in the blink of an eye, their reign came to a sudden and cataclysmic end. What caused this dramatic extinction event? How did such powerful creatures vanish, seemingly overnight? The most widely accepted theory, the one that still dominates scientific discussions today, is the asteroid impact hypothesis. Around 66 million years ago, a colossal asteroid, about 10 kilometers in diameter, collided with Earth near what is now the Yucatan Peninsula in Mexico. The impact released an unimaginable amount of energy, equivalent to billions of atomic bombs. This created a massive explosion, sending debris into the atmosphere and triggering wildfires, tsunamis, and a global climate catastrophe. The immediate effects of the asteroid strike were devastating. The impact caused massive fires to ignite across the planet, and the resulting tsunamis tore through the coastlines. But the true catastrophe came from the dust and soot thrown up into the atmosphere. For months, the skies were darkened, blocking out sunlight and causing a dramatic drop in temperatures worldwide. This impact winter led to a collapse in the planet's ecosystems. Plants, unable to photosynthesize without sunlight, withered and died, and the herbivorous dinosaurs that depended on them for food soon followed. The entire food chain began to unravel. While the asteroid impact is the most famous and widely accepted cause of the extinction event, it is not the only theory. In fact, many scientists believe that a combination of factors contributed to the mass extinction. Another significant player in the fall of the dinosaurs was volcanic activity. Around the same time that the asteroid struck, enormous volcanic eruptions, known as the Deccan Traps, were occurring in what is now India. These eruptions lasted for millions of years, spewing vast amounts of lava, ash, and gases into the atmosphere. The gases released by these volcanic eruptions, particularly carbon dioxide and sulfur dioxide, likely contributed to global climate change. The sulfur dioxide would have created a cooling effect, further exacerbating the impact winter caused by the asteroid. Meanwhile, the carbon dioxide trapped heat in the atmosphere, leading to long-term global warming once the immediate effects of the impact had subsided. This extreme climate volatility would have been catastrophic for the dinosaurs, making it impossible for them to adapt quickly enough. In addition to the asteroid and volcanic activity, some scientists suggest that changes in sea levels might have played a role in the extinction. As the climate shifted, sea levels fluctuated, possibly altering the habitats of marine life. The disruption of marine ecosystems could have had a ripple effect, impacting land-based food sources and ecosystems as well. There's also evidence suggesting that gradual changes in the Earth's climate, long before the asteroid impact, may have begun to stress ecosystems. The late Cretaceous period was marked by a warmer climate, rising sea levels, and increased volcanic activity, all of which could have weakened the dinosaurs and made them more vulnerable to the final catastrophe. Despite the variety of theories, the asteroid impact remains the most plausible explanation. Fossil records show a sudden and dramatic extinction event that wiped out nearly 75% of all species, including all non-avian dinosaurs, at the end of the Cretaceous period. The evidence is clear in the form of a layer of iridium-rich clay found in geological formations around the world. Iridium is a rare metal that is more common in asteroids than in Earth's crust, providing strong evidence that an asteroid impact played a central role in the extinction. But what exactly happened to the dinosaurs in the aftermath of the extinction event? It's believed that the surviving species, mainly small mammals, birds, and some reptiles, were able to adapt to the new, harsher environment. With the disappearance of the dinosaurs, the Earth's ecosystems slowly began to recover, and new species emerged to fill the ecological niches left by the great reptiles. The extinction of the dinosaurs paved the way for the rise of mammals. which would eventually lead to the evolution of humans. Birds, which are direct descendants of small theropod dinosaurs, survived the mass extinction and continue to thrive today. The sudden fall of the dinosaurs, caused by a combination of asteroid impacts, volcanic activity, and climate change, marks one of the most dramatic moments in the history of life on Earth. While the dinosaurs themselves are gone, their legacy continues to influence life today, reminding us of the power of nature's forces and the fragility of even the most dominant species.
This was the dawn of a new era, a time when mammals finally began to step out of the shadows.
This confirms my hypothesis. They were thriving right up until the impact.
The geological layer clearly shows the boundary, Professor.
For millions of years, they ruled the Earth, until a sudden, catastrophic event wiped them out, reshaping life on the planet forever.